Sencha Touch provides a nested list component, which is ideal for navigating hierarchical menus. In this screencast, we'll set up a basic nested list, then find out how to create a detail view for leaf nodes in the tree, and how to enhance the index listing with metadata about each list item. To begin with, in the app.js file, we'll create a new application called nested list demo. Here, we can implement a function called launch, which will be called when the application starts up. We'll just include a single line of code, which instantiates a new viewport. This follows the conventions for organizing a Sencha Touch application, but the viewport is not a predefined component. Instead, we have to roll it ourselves. I've already got a file in the app views directory called viewport.js, and this is where we can configure the main window of the application. To begin with, I'll just create a new full screen panel with some placeholder text, then fire up a web browser to test that the framework is loading OK. It looks as though everything is in order here, so let's start building a nested list. First of all, we'll remove what was previously a plain panel and swap it out for a nested list class. In place of the HTML attribute, we can start filling out the attributes that are required to make a nested list work. First amongst these is the store property, which should refer to a tree store object. We'll need to create one of these, so let's add a new file to the app stores directory and call it musicstore.js. Here we can instantiate a new tree store and configure it with a model and a proxy. I've created a sample dataset and saved it as a static file within this project. This can be accessed at the URL /data/tracks.json. If you wanted to fetch JSON from a different domain than the one that your Sencha Touch application resides on, then it would be necessary to make a JSON P request. But in this case, our application is hosted on the same domain as the JSON resource that we want to fetch, so we can use a plain old AJAX request. The proxy also needs to be configured with a reader, which in the case of a nested list should be of type tree. The root property should match the top level object in the JSON document. In our case, the JSON document groups all objects together under a root property called items, so that is what we'll use here. The store acts as a client-side cache for the data fetched by the proxy. To make sense of this data, you have to create a model that maps each field from the JSON to a property of its own. Here, we'll create a model called listItem, giving it a field for each of the properties defined in the JSON document. Having created a model, we can now wire it up with the music store, which in turn can be set as the store for the nested list component. Finally, we'll have to add both of our new JavaScript files to the index.html file to make sure that they are available. That may have seemed like a lot of configuration, but let's fire up the browser and see what we get for it. There we go. Our JSON data structure has been converted into a nested list. Pretty neat. We can drill down several levels, but when we find ourselves clicking on a leaf node, nothing happens. So next up, let's fix that. The nested list component makes it quite straightforward to create a panel for leaf nodes. The getDetailCard function is called when you tap a leaf node in the nested list. If the function returns a panel, then the view will be updated to reveal that panel. So let's implement the getDetailCard function. Here, we instantiate a new panel and give it a simple template that shows the title of the object, along with any additional information about it. The function accepts two arguments, representing the leaf object itself and its parent. By calling the update function on our newly created panel, we can render the template using the data from the current leaf object. Let's see how that looks. Now, when I click on a leaf node, the list view scrolls over to show a detail panel for the current item. Now, this seed dataset doesn't include anything of interest, but this page could include an article about the item in question, or in the case of this music browser demonstration, it could even include an audio file. Just to show you how flexible this is, I'm going to jump back into the store and change the URL. I've created 3 different JSON files: artists, albums, and tracks. Each one contains the same tree of data, but with different items representing leaf nodes. So if I swap out the URL tracks.json for albums.json, it will serve the same tree of data, but with albums marked as leaf nodes instead of tracks. Now, when I refresh the browser, I get the same nested list as before, except that when I click on an album, I get a detail panel about that album, rather than a track listing. It's not possible to treat every node in the tree as a leaf. You have to pick one level and stick to it. But if you want to show more information about any of the branches, then you can easily override the template. There are a couple of ways that you can modify the text used to represent an item in the list. The simplest way is to provide a value for the display field property. You can use any of the fields in your model, but if you don't specify anything, then by default it will look for a field called text. For example, if I was to override the display field so that it used the model attribute instead, then you'll see that when I refresh the browser that it has changed the value used in each of the list items. In this case, it makes sense to use the text field, so I'll revert this change. The other way that you can change the list text is to implement a function called getItemTextTPL. If you return a string from this function, then it will be used to construct an X template, which gives you a lot more flexibility. Here, I've created a template that examines the model field and adds appropriate metadata depending on what it finds. I'm also going to add a rule to the style sheet so that the metadata looks different to the title. Now you'll see that each artist is supplemented with the number of albums in the system, while each album includes the number of tracks. Finally, each track includes its running time in minutes and seconds. The code used in this demonstration can be found on GitHub. I've created a separate branch for every checkpoint, so each time you see a card like this one, it means that you can check out a snapshot of the code in its current state at that point in the screencast. You can find instructions on how to view these snapshots in the repository's README file. In an earlier draft of this tutorial, I used a simple Sinatra application as a backend. This made the learning curve slightly too steep, so I've revised it to simply use static JSON files instead. The Sinatra application is available on GitHub as a separate branch, so you can still study that code if you feel so inclined.